All right, so let's go through this fourth help and tips file. This is a pretty foundational one. It's actually pretty short too. It's just a few plots and a basic regression, but you're going to use these commands over and over again. So this is a really important base set of R codes to remember going forward. And yeah, if you're comfortable rolling through it on your own, you should be just fine. I don't say anything too different or crazy than what you see here. So if it all makes sense to you just looking at it, great, go for it. So I'm going to work with the NBA data here as I've used before. And there it is. And I'm just going to take a quick check, make sure it looks okay, good. Okay, how do we run a basic linear regression in R? So we use what's called the LM function, as I type it out here. The LM stands for linear model, and that will help us do all kinds of different linear models, and that will make a linear regression for us. Now, I can run a model in LM, but not much is going to happen unless I save it as something or I store it to an object. So hopefully you're getting used to this convention that when you run something or when you make something, you name it. You make it an object, and then you operate on that object, that name, to find out things about your linear model. So to do our linear model, we just start by giving it a name. I tend to use lm.1 to start and then do numbers to keep track of things. I find that's a nice organized way to think about it. And then I write out the function lm, parenthesis. The way this works, you can think about sort of like writing in the formula. If I want to predict, and I'll just sort of write this out here so you see it. So I want to predict games 1 as explained by points per game. What I do is I put the response variable first, then, like the formula, where there's an equal sign, I put this little squiggle, the tilde. I then like to put in a 1 plus. This explicitly, to me, tells me that I have an intercept in my model. And I'll show you in a second why that's important. So to me, the 1 plus stands for I've got an intercept in my model. And then I put in the explanatory variable, in this case, points per game. Finally, you just like everything else, you do a comma, and then to specify the rest of what you need to do, you then put in the rest. And in this case, I need to tell it which data set to pull from. So I say data equals NBA 15. Okay? So I can run that, and now I've got an LM right here, lm.1. Great. How do I actually look at what I did? Well, you can just look at the object itself, and it gives you some information. It doesn't give you all information. Instead, I want you to use the summary command. So you're going to use summary and then the name of your model, and you're going to get a lot of stuff. What do we do with all this stuff? What does all this mean? Well, that's where I made the other video and the interpretation guide so that I could focus on that there. I won't really talk about much else here. But this is all the output that we use to interpret our model and what we need to say for our conclusions. So again, that is all from the summary command. But what I just want you to note from here is that we have a line for our intercept here. And we have a line for points per game, our variable down here. So every term in your model gets a line. Now I mentioned that I did this 1 plus up here. Again, that's to signal to me that I have an intercept in my model, beta 0. R is smart enough that, let's say I want to run a model a different way. Let's just say I didn't include the +1. And I ran a new model called LM2. And I used the same response and explanatory variable, but I didn't include the 1 plus. I use summary, the name of my model. It gives me the same thing. That's because R will always include an intercept value, an intercept in your model, unless you tell it not to. I'm not going to ever have you run a model where you don't need an intercept. That's a different set of considerations that we won't worry about here. The point being, when you write out your model, you can just use the variables that you're going to have. Or, as I like to do, and as you will see, you can also throw in the 1 plus as a stand-in to tell you that you're running something that has an intercept. It just makes more sense in my brain to run a model where there's something in place of every term. And really, in terms of interpreting our output, that's it. We will deal more with this later on, not this week or the next week as much. But we can also look at something called the ANOVA table with the ANOVA command. And that gives us ANOVA output, which you will see in the future. But anyway, so this gives you more information that we'll work with. Great. So another important skill is to collect our predicted values. Remember, our model is predicting average values for our response variable. It's trying to predict the data. So how do we collect those? Well, it's just the predict command and then the name of our model. And so I can run that. And what it has done is it has taken the data for the explanatory variable, plugged it into our model, and given us the predicted response variable. So this is great, but it's not very useful, really. I like to save it as something, so I tend to save it as y hat. So I say, great. All the predicted values from my model, all 1 through 30 of them, store them as y hat. And then I can work with them. Similarly, we've learned that the model, each prediction results in a residual because our model generally does not predict the exact data value. There's some kind of error when it makes a prediction, and we collect that with a command called resid, and then the name of our model. But similarly, it just spits out a bunch of residuals. So we see that it overpredicted on the first one by 13. It underpredicted on the second observation by -4, etc. But I like to maybe collect that so I can do things with it. So I'll save lm.1resid as the name. We'll do this in later weeks, but you can do something called standardized residuals, which is just takes the residuals and divides them all by, you can think of it like a standard deviation, so that that they all have a mean of 0 and a standard deviation of 1. You don't need to do this just yet, but it's here so you see it. And to do that, the command is rstandard. So these are the residuals that have been standardized to take on certain values. I can store those. And you don't need to do this, but if it's easier for you, if you like to think of it this way, you can save all these things into a data frame. So I can make a data frame out of my predictions, my residuals, and my standardized residuals. It's a little tedious because I don't think you're not going to necessarily need to do that, but just showing you that it's something to keep in mind if you want to try that. And I now have a data frame with my predicted values, the residuals, and the standardized residuals. Again, you won't really need to do this. You can do things sort of just how I have them up here, where you produce one thing at a time. But maybe you'll do something more sophisticated after this class than this, and you will just want to save these things. And you can see now that you can do that. Great. So with that, we can then check our assumptions, and we will pick up with that in the next video. So this is the end of part 1.